Last problem is going to come in two parts, and we're almost at the 2-hour mark. Part A asks to convert two Cartesian coordinates into polar coordinates, which we could do reasonably quickly. We're given that the conversion for Cartesian into polar is x is equal to r cosine theta, and y is equal to r sine theta. Because on the unit circle, x is cosine and y is sine. So if by these coordinates you have 1 equal r cosine theta and 1 equal r cosine theta, and then by the second set of coordinates you have root 3 equal r sine theta and 1 equal r sine theta. That's what you have so far. And then on the top, since these are just basically the same, in order for r cosine to be 1, you would have to have theta is equal to pi over 3 and r is equal to 2. Why? Because of this root 3 on the unit circle. Because remember that sine pi over 3 is equal to root 3 over 2. So we got to make all of the r's for all of these conversions equal to 2. And so finally you have this 1 equals r sine theta, which turns into r is equal to 2. Theta is going to be equal to, in order to make it 1, it would have to be 1/2. So sine being 1/2 is theta is equal to pi over 6. There you go. That's part A. And then lastly, but not least, part B. Find the area of one loop of r is equal to cosine 2 theta. So first things first, we got to draw this. Your r starts here, ends here. It says in the problem that it's a 4-leafed rose. So what we're doing is going to start from the origin, and it's just going to go into a curve here and reflect it about the x-axis. It's also going to look the exact same. Now we'll just do this for all of these for demonstration. Notice that this function is cosine 2 theta. And notice that when cosine 2 theta, when theta becomes pi over 4, or otherwise known as cosine pi over 2, cosine pi over 2 becomes 0, which is exactly what's going on here. So this is going up to pi over 4 as our limit. And since our theta is going to be pi over 4, that's going to be our angle of our image that we're going to reflect everything off of. Now, the problem says to find the area of one loop of the 4-leaf rows. So you got to take the area of this function and multiply it by 2. And in order to do that, we need the area formula of the curve, which would be equal to 1/2 integral from a to b cosine squared 2 theta d theta. And now that we have trying to find the area of one leaf instead of 1/2 of a leaf, we multiply this 2 from outside the integral, and then that cancels to equal 1, so that becomes obsolete. In order to remove this square here, we use the power reduction formula. And by the way, our limits are from 0 to pi over 4, as I explained earlier. With the power reduction being 1 plus cosine 4 theta over 2 d theta. Take the 1/2 out. And what remains is 1 plus cosine 4 theta d theta. Take the integral of that, you get 1/2 times theta plus sine, 1/4 sine 4 theta. From the limits 0 to pi over 4. So computing this, we get 1/2 pi. Actually, let's just distribute the 1/2 to make this simpler. So this becomes theta over 2 and 1 over 8. So now pi over 2, actually pi over 8, plus 1/8 sine of pi minus 0 over 2 is just 0. Sine of 0 is just 0, as you could see by this. So this is just 0. Sine of pi is also equal to 0. So this becomes 0 as well. And what we're left with is pi over 8. Now it's the end of the practice test. And this is how long it would have normally taken to do, given that everyone was prepared to do it and everything like that. But if I made this sound a little tedious, I do apologize. But this is normally just the sort of things that you would remember on a note card or something, and sort of the creative things that you would manipulate with the integrals and such on the tests. So this has been helpful. I'm glad that it was. And if you have any questions, please let me know. And I'll see you later.